Here's another video in the series about graphing data in science. In particular, this video is about what is slope. It isn't simply the m in y equals mx plus b. What is slope? Okay, yes, it is the y and or the m in y equals mx plus b. Yes, it is rise over run. And yes, it is the rate at which the dependent variable changes relative to the independent variable. But it's so much more. Alright, so let's look at an example of a slope in a linear relationship. So in this case, somebody took a set of measurements of the diameter and circumference of a variety of round objects. When I go to graph it, you'll see that it looks like I have a fairly straight line. But then when I take my trend line, I get a line and I get an equation that says y equals 3.1571x minus 0.0183, which means it's going to cross the y-axis at slightly less than the origin. And I've got an r-squared value of 1, which means that this particular set of data matches pretty closely. But let's take a look at what is actually going on here. Alright, so slope is the definition of the relationship between two variables. So now, the equation we got of the line, again, is y equals 3.1571x. In this case I said plus, but it's still right around the origin. The equation of circumference is c equals pi times d. Alright, so in this case, c equals the y, d equals the x, and m, the slope, equals pi. Now let's take a look at these. If I do a percent error calculation between the value of pi and the slope I got from my measurements, I get a percent error of 0.494%, which means I'm pretty darn close. So really, when you look at slope, it really does have a direct relationship with the equation of whatever data you may be collecting. Alright, so now let's look at one where we have a non-linear relationship. Alright, so in this case it's the period of a mass on a spring. Alright, so in this case the spring constant, or the stiffness of the spring, is 25 newtons per meter. And I have a list of masses and the times associated with those masses. Now, when I did my original graph, I thought that maybe it's direct. Okay, it is increasing, but if you look, y equals 0.5379x and plus 0.6574, and you also get the r squared is 0.9765. Yes, it's close to 1, but let's try a power relationship and see if we can get any closer. Alright, so here's the power relationship, and I get y equals 1.2566x to the 0.5 and an r squared of 1. So that means this is a perfect fit. And this x to the 0.5 means this is a square root function. So I'm really looking at a root relationship. Alright? Now let's look at a root relationship function and see how we did in terms of our information. Alright? So the graphed equation was 1.2566 times x to the 0.5. The actual equation is really t equals 2 pi times the square root of m over k, and that 2 pi, so the coefficient I got from the equation is 1.2566, and 2 pi over the square root of 25 is 1.257. So if you look, you'll see the coefficient is very, very close to the equation. So again, here the slope is actually telling us something about what the equation looks like and what coefficients in the equation might look like. Now, Just because slope looks like something doesn't mean it really is. Now, let's look at a case where the slope is 0. In this case, we have a spring mass that's in kilograms and the period. So when I take my equation, I get y equals 0.0439 x plus 0.1867. And I get an r squared value of very, very close to 1. And you can see by this thing. But in this particular case, I have a very, very small slope relative to either the spring mass and the periods. So it is small relative to these. Therefore, you can say that the slope is approximately 0 and there is no relationship between spring mass and the period of a pendulum, or period of a mass on a spring. Alright, so as a review, slope is important to the relationship between two variables. It is an important place in determining what the potential equation might look like. The shape of the graph doesn't always tell you the slope. Always calculate or review the slope when determining the relationship. Okay, and a lot of times a seemingly direct or indirect relationship can actually be no relationship if the slope is 0 or is close to it. Use the r squared value to help you determine this. Thanks.